So today we're going to be talking about combinations of n objects taken at r at a time. So a combination is a selection of r objects from a group of n objects without regard to order. So this is when order doesn't really matter. You'll notice when we talked about permutations, we talked about first, second, and third, or numbers not being repeated, or things like that. So that's a permutation. Combination is when you're not taking into order. And so our numbers, our values, are going to be small in combinations. Okay? So here's the equation for combination. It's n factorial over n minus r factorial times r factorial. So we're actually dividing by those repeated amounts. And we denote it NCR right there. Okay? All right, so example 5. It says the State Department of Transportation plans to develop a new section of interstate highway and receives 16 bids for the project. The state plans to hire 4 of the bidding companies. How many different combinations of 4 companies can be selected from the 16? So we'll notice it doesn't say a specific amount. It doesn't say the order in which they're selected, and it doesn't say bid number 1, bid number 2, bid number 3, and so on. So that means this is a combination. We're looking at 16 companies, and we're looking specifically at 4 at a time. And so this is 16 combination of 4. And again, we have decimals, so we could use that. And we're actually going to go to the functions, NCR, and we're going to use 16 and 4. And so there's 1,820 different combinations of the 4 companies. Okay? Here's a guided practice problem that talks about employees from the department. You can try now. All right, so just to summarize some counting principles. So the first one, fundamental counting principle. It says if there's m ways in the second event, could be n ways. You just multiply them. If we're looking at some different ordered arrangements, there's n distinct. That would be n factorial. Then we have permutations in which order is taken into account, and it's important. We have distinguishable ones when we have repeated things, like the example we looked at in the other section was different types of houses. So single story, 2-story, those are repeated houses. Or there's combination when order does not matter. Okay, so let's use all this to find the next couple examples. So the first one, it says a student advisory board consists of 17 members. 3 members serve as the board chair, secretary, and webmaster. Each member is equally likely to serve at any position. What is the probability of selecting at random the 3 members who are currently holding the 3 positions? Okay, so now it says the important thing we're going to look at is the last section. It says, what is the probability of selecting at random 3 members who currently hold the 3 positions? Okay, who currently hold the 3 positions. So notice we are looking at n is going to be 17, right? We know that. And r is going to be 3. But what we have to decide is, does the order matter? Okay? Now, since these people are already holding position, it means that we're selecting a specific order of 1, 2, and 3. We're specifically picking someone who is the board chair, who is currently the board chair, secretary, who is currently the secretary, webmaster, who is currently the webmaster, which means the order does matter. So this is actually a permutation. And so we're going to pick such. Okay, so we go to our calculator and we look at our function, permutation. We're looking at 17 and we're looking at 3 specific. And so there's 4,080 different. 4,080. So what does that mean? It means what's the probability? 1 way out of 4,080 that this happens. That's our probability. Okay, and here's a guided practice problem that you can try as well. Now, example 7, it says finding, you have 11 letters consisting of 1 M, 4 I's, 4 S's, and 2 P's. What's the probability of randomly arranging in order, and what is the probability that the arrangement would be Mississippi? So think about this. This is those distinguishable permutation problem because we have repeated I's. And so we would say this. We know that there's 11 letters, right? That's our N. Now, N1 is going to be the number of M's, which is just 1. N2 is going to be the 4 I's, so it'll be 4 factorial. N3 is going to be the 4 S's, 4 factorial, and N4 is going to be the 2 P's. Okay, so if we added, just making sure, 1 plus 4 is 5, 9, 10, 11. So they do work out. And so we go to our calculator, and we do 11 factorial divided by 1 factorial times 4 factorial times 4 factorial times 2 factorial. And I find 34,650. 34,650. So probability-wise, this is, it would be 1 out of that, which is 34,650. Okay, so your probability is not very good. Okay, here's a guided practice problem that you can try too. Example 8. It says, find the probability of picking 5 diamonds from a standard deck of playing cards. Okay, so let's think about this. The probability of 5 diamonds. Okay, so diamond, 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 right? So think about it. Probability of the first diamond is going to be 13 out of 52, right? There's 52 cards. Then the next, okay, notice it says picking 5 diamonds, and basically they're not saying one is going to be replaced, right? It doesn't say replaced, so we can assume that they're gone. Okay, then the next diamond will be 11 out of 52. Next will be 10 out of 52. And finally, the last one will be 9 out of 52, right? And so we can figure this out. And so we'll do that. We'll just do, okay, we can do it the old school way, which is actually just multiplying it all out, right? So it would be 13 out of 52 times 12 out of 52 times 11 out of 52 times 10 out of 52 times 9 out of 52. Excuse me. I said 52 every time, but you know what? Those would be going down as well. So 51. And then after 51, there'd be 50. After that, there'd be 49. And after that, there'd be 48. So really, oh, this isn't going to give it to me as a calculator. As a so rewriting that, -4 would be 3 decimal places. So it would be 0.000495. So not very good, okay, of picking 5 diamonds in a row. Okay. Last problem we're going to look at, example 9. A food manufacturer is analyzing a sample of 400 kernels of corn for the presence of a toxin. In the sample, 3 kernels have dangerously high levels of the toxin. If 4 kernels are randomly selected from a sample, what is the probability that exactly 1 kernel contains the dangerously high level of toxin? Okay, so this is what we have to think about. We have to think about combinations, right? And so basically, it's how many different combinations is there if I'm taking 4 kernels that 3 of them have dangerously high out of the 400. And then if I'm taking 4 kernels, what's the probability that one of them is going to actually have the toxin in it, right? So let's look at them in 2 separate parts. So the first one, my N is 400, right? Okay, and I'm looking for R. I'm going to say, actually, you know what? We'll do it like this. We know that N is 400, right? And so the probability of having the toxin is the 3 kernels out of 400, right? That's the probability of a toxin. Now, it said if 4 kernels are randomly selected from the sample, what is the probability that one of them has the dangerously high level of the toxin? So that right there is going to be a combination. It doesn't say the first or the second one. or whatever. So we're going to be looking at n equals 4 because we're taking 4 and we're taking one at a time, right? So 4 combination of 1. So we go here. Notice that's 4, right? So that would just equal 4. And so we're going to take this divided by, basically, well, it's, excuse me, the other way would be this divided by this. So 4 divided by 3 out of 400. Okay, and so we go to our calculator. And so that's going to be 0.03. So about 3%, right? So if 4 kernels are selected, what's the probability that exactly one of them contains the high level? It's 3%. Okay? All right, let me know if you have any questions, and good luck.